Okay, hi guys, this is me again. My name is Joseph RG, Joseph AGKRG. We are continuing on our lecture on probability. Remember, I told you that I will move very slow, step by step, to make sure that you understand the concept of statistics, so that you will no longer be afraid. You will not be scared of statistics by the time you finish my lectures. Okay? Now, let me tell you this. I once have a statistics class. Actually, I'm still teaching statistics. So in one of my classes some years back, one student forgot his textbook. Actually, it was a lady. She forgot her textbook in class, and we went home. When we came back next week, the textbook was still there. The statistics textbook was still in the class on the exact spot where she left it. Nobody stole it. Nobody wants to steal a statistics book. That will tell you the extent of fear that people have about statistics. But I'm telling you that by the time you finish my class, or by the time you finish watching all my videos, you will never be scared of statistics. Okay? So let's begin. Today we'll be looking at the probability, the basic rules of probability. The first rule we'll examine is called the rule number 1. According to this rule, the probability of an event E is a number between 0 and 1. And also either 0 and 1, or it can be 0 and 1. So it is between 0 and 1 inclusive. This is how we write it. The probability of an event E can be 0 or less, or can be 1 or less. Sorry, let me rephrase it. The probability of an event E is a number between 0 and 1. That's the best way to put it. It can never be less than 1. It can never be bigger than 1. So if you're solving a probability problem and your answer is 1.3, that means you are wrong, because the probability of any event can never be bigger than 1. And remember, that 1 represents 100%. Also, if you are solving a probability problem and your answer is negative 0.35, that will tell you automatically that you are wrong, because the probability of any event can never be negative. Okay? So that is for rule number 1. Let's look at rule number 2. Rule number 2 says, if an event E cannot occur, then its probability is 0, which means that the probability of an impossible event is 0. So look at it here. This is how I place it on a chart. Impossible, 0. Certain. So if event is going to happen, if you are very sure it will happen, then the probability will be 1. That means you are 100% sure. But we're not worried about it now. We are looking at rule number 2, which is the probability of impossible events. That will be 0. A good example is this: getting a 9 when a single die is rolled. Of course, I'm sure you know what a dice is. If you don't, let me show you how it looks. See? It has 6 sides, and all the sides has numbers. Like this one has 5, 4, 6. So you cannot see a number 7 on this dice. Getting a 7 in one dice is impossible. That will show you what rule number 2 is talking about. Okay? Let's look at rule number 3. It says, if an event E is certain to occur, then the probability is 1, which means that you are 100% sure that it occur. A good example is this. The probability of getting a number that is less than 7 in a single dice is a certain event. Again, look at that dice. All these numbers here are less than 7. So the probability that you get a number that is less than 7 when you roll this die is 100%. Okay? So that is rule number 3. So I used to joke with my students. I tell them the probability that I will have my breakfast is 1 because I love my breakfast. Okay? So it is a possible event. Okay? Next rule is rule number 4, which says the sum of the probabilities of all the outcomes, okay, in a sample space equals 1. With this sample space in our previous lectures, I'm sure you still remember this sample space means the set of all possible outcomes, okay, of a probability experiment. Now look at this. It's saying that each of the units of that sample space, if you can calculate their probabilities and add them, it will add to 1. Let's use an example. I think this is rule number 4, example of it. It said, in a roll of a dice, a fair dice, each outcome in the sample space has a probability of 1/6. Because in a dice have 6 sides, so the chance of 1 showing up when you roll it is 1/6. That's what it was telling us here. 1/6 chances. Okay. All right. So that the it says, hence the sum of the probabilities of each of these. See, 1 has a probability of 1/6 chances. The number 2 showing up has a probability of 1/6 chances. The number 3 showing up has a probability of 1/6 chances. All the way to the last number, all of them have the probability of 1/6. Okay? So when you add them all, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, that will give you 6/6, which is 1. You can even add them using a calculator. Okay? So you can say, you can do it in this form. Normally I use, I try to use parentheses. What is the parenthesis right here? Okay. I put the first parenthesis. Oh, excuse me, let me turn it on. Clear it. So the parenthesis says here, it's right here. So I'm gonna do, here have 1 divided by 6. Okay. I close the parenthesis. Then I press my plus sign. Okay, under parenthesis. So I have 1 divided by 6. I close my parenthesis. Then I apply my plus sign again. Okay, I got 1 divided by 6. So the third one. Okay, then the fourth one is 1 divided by 6. Then the fifth one is, okay, 1 divided by 6. Okay, then the sixth one, under parenthesis, 1 divided by 6. Okay, you can see all of them here. Then I press the equal sign here. That will give me the answer. The answer 1. You can see right here. 1 right here. Okay. So that's what I got here. You can see right here. 1. So that proves that is a proof of a simple proof of rule number 4. Okay. Rule number 5, we call it the complement rule. We call it the complement rule. I normally tell my students that the complement rule is all about the opposite. Their complement of sitting down is, if the event is sitting down, then your complement of that event is standing up. If the event is having a breakfast, the complement is not having a breakfast. So the opposite, actually. So I wrote here that the set of all outcomes in a sample space that are not included in event E is called a complement. Look at this chart here. This is the event E. Everything outside are not included in event E. So they are the complement of event E. You can see how we write it. E prime. So with this small symbol here, we call it a prime. It is a symbol for E complement. So look at the complement rule right here. The probability of event E plus the probability of event E complement equals 1. The probability of event E is equals to 1 minus the probability of event E complement. And also, the probability of event E complement equals 1 minus the probability of E. Now, don't worry, this formula might look, you might say, okay, I'm going nuclear, but I'm not. You will see how we apply this formula. When you see how it is used in one example, at least, you will discover that it's actually easy. So we're going to come to that in a few minutes. Let's look at this example here. It says find the complement of each event. The first event is rolling a dice and getting a 4. The second event is selecting a day of the week and getting a weekday. Okay, so I simplified it in a chart, this form. The first event is this: rolling a dice and getting a 4. The complement means not getting a 4. Yeah. That means not getting a 4. So that means it means getting 1, 2, 3, 5, and 6. So getting any number other than 4 is the complement. Another one is this: selecting a day of the week and getting a weekday. The complement is getting a Saturday or a Sunday. So getting a weekday is, well, weekdays include Monday, Tuesday, Wednesday, Thursday, Friday. So these are the weekdays. Saturday and Sunday are weekends. So the event, selecting a day of the week and getting a weekday, the complement is the opposite, which is selecting a weekend. And that means getting a Sunday or a Saturday. Okay? All right. So let's try another example. You survey a sample of 1,000 employees at a company and record the age of each. Find the probability of randomly choosing an employee who is not between 25 and 34 years. See? So he said you want to select an employee who is not between 25 or 34 years. This means selecting a complement of 25 or 34 years, which means selecting any person, any employee who is not in this age group. So this is where we're going to use this formula here. See this formula right here. Hope you're ready. Let's do it right here. So I presented it here. so you can see it very clear. All right. Now, if you look at the chart, these are the age, see? And the question was saying, selecting an employee who is not between age 25 to 34 years. So that means here. So let us first of all find the probability of selecting this age group. Then after that, we can apply the formula here. So this age group, how many of them do we have in this company? 366 of them. Out of how many people in the, how many employees? Out of 1,000 employees. So that the probability of selecting an employee in this age group, 25 to 34, is this frequency that we have here, which is 366, out of all the employees, which is 1,000. And that will give us 0.366. Now, this is the probability of selecting an employee in this category. But remember, what we are looking for is the probability of selecting an employee who is not in this category. So to do that, we use the complement rule here. The probability of event E complement, which is selecting an employee who is not in this group, is 1 minus the probability of E, which means the probability of selecting an employee who is in that group. So now we plug the number. We have the answer already for E here as 0.366. So we plug it into this formula here. That will give us 1 minus 0.366. Even though I have it as a fraction here, you can just do it this way as 1. See 1 here. Press 1. You press the minus sign right here. Minus. Press the point here. Point. And then you're going to press 0.366. So you have 3 here, right here. Okay. And 666. You can see right here. So you can see it very clearly. Now, when you press the equal sign, which is right here, you get the answer right there. 0.634, which is what I have here. Okay. So you have 63.4% chance or probability of selecting an employee who is not in this age group. Okay. See, I told you the formula is easy. When you add it, when you apply it, when you see an example where of how it is applied, you're gonna love it, guaranteed. I'm sure you are having fun by now. Okay. Now let us round up. Actually, this is what concludes our lecture today. In my next lecture, I will show you how to use the 3 diagrams to solve the probability of an event, or to find sample space and also calculate the probability of an event. So don't forget to subscribe to my YouTube video channel so that you will always know when I have a new lecture available. Thank you, guys. Again, my name is Joseph AGK or G. I'll see you soon. Bye-bye.